Hey, this weekend I was sick and I used one of these things. It's hard to see because it's green. Maybe I'll put it in front of my green shirt. Uh, it's a thermometer, digital thermometer. If you look really closely in the very tip of this thing, you can see a little knob inside there, inside that plastic with two wires coming out of it. That is a thermistor and it's used to tell temperature by having a resistor it literally is a resistor that's responsive to temperature. When the temperature changes, the voltage changes because the resistance changes in a circuit. And so what we're going to do is use that thermistor, that tool, to create a prototype that's a crude version of that thermometer that I used when I was sick this weekend. So let's get started. Our objective is to make a temperature checker, kind of like this thermometer that I was just talking about earlier, only our display won't be as sophisticated as this. It will just have three LEDs that function as a bar graph, but we will send more precise temperatures to the serial monitor on our device. Here's a little overview of how it works. I'm going to take my fingers and pinch the thermistor to add some body heat, and you can see that one light lights up, then the second, and then the third. I take my finger away, the temperature begins to drop, and then the lights gradually go out one by one. That's kind of what we're after today, trying to build this project. Here are the parts that you're going to need. So stop the video and assemble these things. Just grab your jumper wire kit. You'll need three 1 kilo ohm resistors or 1,000 ohm resistors, one 10 kilo ohm resistor, three red LEDs. Doesn't really matter if they're red, but if you have three red LEDs, use those. And then a thermistor. So a thermistor you haven't seen before. This has two little wires coming out of it, and it looks like the two wires are held together by like a black little dot of glue or plastic. That's what your thermistor is like. Find those items and then start the video when you have them together. I'm not going to be able to use Tinkercad to guide you through the build process because Tinkercad doesn't have a thermistor in its kit. It has a different type of temperature sensor. So I'm going to use a different utility called fritzing where we can build, but we can't write code. I have an Arduino breadboard, the thermistor, three 1,000 ohm resistors, one 10,000 ohm resistor, and then three LEDs. Let's start out by putting the LEDs on the board. So I'm going to place these LEDs kind of one right after the other. I'm going to leave a little space in between them. And you'll notice that the bent wire, that's the long side, that's the positive side, or the anode is on the right-hand side. We're going to have outputs going into the anode side of each LED from three different pins, pins 2, 3, and 4 on our Arduino. So I'm going to connect a wire from pin 2 to the anode of my first LED, pin 3 to the second one, and pin 4 to the third. And I'm going to bend these wires a little bit just to get them out of the way. And allow you to see a little bit better. The other side, the cathode side, is going to go to the ground rail of my breadboard. I'm going to move this LED over because I don't have any holes that are going to line up. So I'm just going to move it to there. And that means I have to move this connection over to there. And now I'm going to take one of my 1,000 ohm resistors and use that to connect the cathode side of my LED to the ground rail. I'm going to do that also on the next resistor over and on the third resistor over. So all three of my LEDs have an input from Arduino and they are all grounded as well. The next thing I'm going to do is place my thermistor on the board. So I'm going to find a location here, just spot it on there. One side will be connected to the positive rail. So I'm going to draw in a connector between the positive rail and one of the two wires of my thermistor. It doesn't matter which wire. And I'm going to make that red because I'm comfortable with red being positive. This is also going to be grounded with my 10,000 ohm resistor. So I'm going to take that 10K resistor and attach that to the negative rail or the ground rail of my breadboard. This thermistor is going to send a signal to Arduino that's going to help us make decisions in our code about which LEDs to light up. So I need to connect this to one of my analog in pins. So I'm going to use pin 0, A0, make that connection. And I'm going to turn this, I'm going to make that yellow. And I guess there's really only one more thing to do, and that is to make sure that our breadboard has power and ground. So I'm going to connect my +5 to the positive rail, make that red, and I'm going to attach the negative rail to one of my grounds. Okay, so now everything is hooked up the way we need it to be, and it's time to write some code. Let's start entering some code. Now, there's going to be some complicated code here. Make sure that you're paying close attention. Feel free to stop the video and catch up when you need to. It's important that you spell everything right, and there's a lot of numbers in this code as well. We have two lines of initialization that come before setup. The first one is to declare a const int. So remember, int is an integer variable. That's a variable that's a whole number. And const int means that the rest of the code after this can't modify its value. This value is going to be named, or this variable is going to be named sensor pin. SENSOR for sensor, and then capital PIN. So that's going to be my name. You can name it anything you want to, but that's what I'm going to call it. So it might be a good idea to use my same name so you don't get confused. A0 is what the value that we're going to assign it to. Now A0 is that analog in pin that we wired up our thermistor to. So we're renaming that pin sensor pin and leaving that variable assigned that value. The next variable is also going to be a const, but it's not going to be an integer. It's going to be what we call a float. And a float is a value that can have decimal values. And it actually has to have decimal values. We're going to name it base temp. BASE, capital TEMP is the name I'm giving it to it. And we're going to assign it a value of 28. But because this is a float, it has to be decimal, so 28.0. Now this is just kind of a reference temperature, 28 degrees Celsius. We're going to use it later on in our code. Those are the only two lines of initialization code. In our setup, we're going to do two things. One, we're going to turn on the serial monitor. How we do that is we go serial dot begin, and then in parentheses we have to say how fast we want the serial monitor to communicate. So we're going to put 9600 for 9600 bits per second. So this just turns on the monitor on our computer so that we can monitor the values that we tell it to print from our code. You'll see what this is used for later on when we finish the code and start running it. Now we're going to just do some pin modes and digital writes, and we're going to do these a slightly different way. Instead of putting individual lines for each pin, we're going to use a for loop. So here's how you do it. Type the word for and then open up parentheses. So how a for works is you pick a variable, and then you have the variable start and end at a certain point, and every time you go through the loop, you do a number of commands, could be just one command or two. You do these commands and then you increase the value of this variable until it reaches a certain value, and then you stop. So here's how this works. We're going to declare this variable called int, and its name is going to be I. Or it's an int variable, and its name is going to be I. It's called I. We're going to assign it a starting value of 2, then a semicolon. And then we're going to say I less than 5. And then semicolon. And then we're going to go I plus plus. Now here's what this line of code is saying. It's saying this letter I, this variable I, we're going to start at 2, and we're going to add to it 1 every time we go through this set of commands until I is 5, and then when I reaches 5, then we stop doing those commands. That's how that works. So I starts at 2, it ends at 4 really, because once it gets to 5, it's not going to do the code anymore. And the I++ means after every loop through this 4, you're going to increase I by 1. So just like after an if, you close, you open and close curly brackets, then enclose the things that you're going to do inside this for loop. So one is going to be pin mode. So remember that has to be spelled lowercase pin and then uppercase M on mode. And the pin is going to be I. So the first time we go through this loop, pin mode will be 2, and it will be an output pin. Remember, output has to be all capitalized. Having some trouble typing here. Close that with a semicolon. And then the second one is a digital write. Remember, the W in write has to be lower or uppercase. And it's going to be pin I, and we're going to make it low. So as it goes through this loop, it's going to make, the first time through, it's going to make 2 an output, and it's going to write 2 low. Then it's going to increase I to 3, and then it's going to make 3 an output and 3 low. And then it's going to do it again for 4, but once it gets to 5, it's going to stop doing the commands inside these curly brackets. That's the end of my 4, so I'm going to close that curly bracket. Oh, Arduino already did that. My editor did that already, so I don't need that curly bracket. It was already there. Okay, now loop. This is where it starts to get really complicated. The first thing we're going to do is we're going to create another variable. It's an integer variable, and it's going to be named, I'm calling it sensor val. So the value coming in from the sensor is what I was thinking about when I chose that name. Equals analog read. And that has to be spelled just that way. So we're reading pin A0, which we have named sensor pin. So it's going to read pin A0, take that value, which will be between 0 and 1023, and it's going to assign that value to this variable called sensor val. Next line, we're going to create another variable. And this one is like a float, only it's double precision. So we call it a double. The name of this variable is going to be temp k. And here's what we're going to assign it. There's a little bit of math going on here. We're going to take the base 10 logarithm. If you don't know what that means, if you haven't had that in math yet, don't worry about it. Just type it this way. You'll be fine. Just doing a little math with the voltage that comes from that thermistor. In parentheses, 10,000 is what's going to go in there. But this is a float type variable, so that means we have to make it 1000.0. And then times, and then we're going to open parentheses, and then we're going to open another set of parentheses. Now you can see that your editor is automatically closing parentheses behind us, so keep an eye on that. What we're multiplying this by is 1024, so 1024.0, because this is, remember, not an int variable, divide by sensor val, and you got to spell this the same way every time, minus 1. And then you have 3 closed parentheses after that. Finish that off with a semicolon. If you can't follow what that's all about, that's okay. You don't have to. The engineers who designed this thermistor just tell us how to use it. So now we have a kind of a voltage coming in here that we can translate into an actual temperature in the Kelvin temperature scale, which is a scale that scientists use. It's an absolute temperature scale. If you haven't heard about Kelvin temperatures, no big deal. You can learn a little bit about that as we continue to write this code. Now this is the most complicated line in the whole sketch. We're now going to reassign temp k to a new value based on some calculations. So it's 1 divide by, and then we're going to open a set of parentheses, and then we're going to type in a complicated number, 0.0011291148. Where does that number come from? From the engineers who designed this thermistor. Plus, and then we're going to open another parenthesis. Here's another fancy number, very precise number, 0.000234,125. Plus, and then we open another set of parentheses, and then 0 point, and then 7 zeros, 1, 2, 3, 4, 5, 6, 7 zeros, and then 876741 times the old value of temp K times the old value of temp K again, so we're multiplying by temp K squared, and then we're going to skip past one closed parenthesis and then the second closed parenthesis, and then we're going to insert in just before the last closed parenthesis another multiply by temp K. Close that line with a semicolon. Okay, so the number that comes out of this line of code is the temperature in the Kelvin scale. Kelvin scale, nobody really uses that very much except for scientists in some situations. So we're going to convert our temp K to a temp C, which is the Celsius temperature. So I'm going to make a new value. It's a float. It's going to be called temp C. And here's how you calculate it. The Kelvin temperature is the same size as the Celsius temperature. The only difference is that 0 kelvins, which is the lowest possible temperature that exists, is 273.15 degrees Celsius below 0. So we will take temp K, which is always going to be 273.15 degrees higher than the Celsius temp, and subtract that number, 273.15, from temp K. And that's a Celsius temperature. Close that with a semicolon. Next, we're going to use Fahrenheit temperature. It's used in the United States, probably the only place it's used. We're going to call this new variable that calculates or stores our Fahrenheit temperature, temp F. And here's the conversion. If you take temp C, the Celsius temperature, and you multiply by 9/5, so how we're going to do that is, times 9, but it has to be 9.0 because this is a float, divide by 5, but it has to be 5.0. And I think we want to make sure that we put parentheses around this numerator here so that it does that operation first. And then you have to add 32. So plus 32, but it has to be 32.0 because remember this is a float. All right, so that converts our Celsius temperature into Fahrenheit temperature. Okay, so now we have a Kelvin temperature, a Celsius temperature, and a Fahrenheit temperature. Next, we're going to print these things. So we're going to put in a command that says serial.print, and it will print what we want it to print, the value of the variable we want it to print. So we put parentheses, and first we're going to print the Kelvin temperature, which is stored in that variable called temp K. Don't forget your semicolon. Then we're going to put a label. So we're going to do a serial.print, and then I'm going to put quotation marks, which means just print literally what's in the quotation marks. Don't look for a variable value. Kelvin. And then I'm going to just leave a space there. Then I'm going to do serial.print And then I'm going to print the Celsius temperature, which is stored in temp C, and then a label. So serial.print. And then in parentheses, I'm going to put degrees C. And then Fahrenheit. So another serial.print. And now temp F. And then this is going to be the end of the line. We're going to start a new line because we have printed all three of the temperatures. So I'm going to put a label in here, but I'm not going to use serial print. I'm going to use serial print ln, print line, which means print this, but then start a new line. And the label, I'm just going to use deg F, degrees Fahrenheit. So that will print out the Kelvin, Celsius, and Fahrenheit temperatures with labels on all of them to my serial monitor. Okay, so that takes care of calculating the temperatures and printing them to this serial monitor. I'm going to skip a line here. And now let's put in the code for controlling the LEDs. So here's how we're going to do this. We're going to make a decision based on how the temperature in Celsius relates to that base temp that we defined earlier. So this line of code is going to say if, so we're making a test here, temp C is less than base temp. Remember, you got to spell it the way you spelled it up. Then you're going to do these things. So we'll open a curly bracket. And then we're going to do a digital write. And then pin 2, which is the first red LED, is going to be low. Oops, semicolon. And the other two are also going to be low. So I'm going to copy this. And paste it 2 times. And just modify that. So pin 3 and pin 4 are both written, also all 3 of these are written low. So what that means is if the temperature is less than 28 degrees C, no lights light up. Okay, so there's a closed curly bracket that's already been put in there. After that, we're going to put an else. But this isn't going to be an else like we've been using before. It's going to be an else if. So there's going to be another test. So if the base temp, or if the temperature Celsius is not less than the base temp, then we're going to do another test. If temp C is greater than or equal to base temp, and also, which we put in this code with 2 ampersands, temp C is less than base temp plus 2.0, then we're going to do some other stuff. Now this is all going to be digital writes, so I'm going to copy and paste those 3 lines. But in this case, I'm going to turn on that first LED. So what this is saying is if the temperature is bigger than 28 degrees, but it's less than 30 degrees, then turn on the first LED. So that else if is closed. We're going to make another else if. And we're just going to make it go up by another 2 degrees. So now we're going to say if temp C is greater than or equal to base temp plus 2.0 and temp C is less than base temp plus 4.0, then we're going to do that series of digital writes a different way. So now 2 is going to be high, so the first LED will be lit, and the second LED will also be lit. So that else if is closed. And then we only have one more LED, so we can just go else at this point, and then open our curly brackets, and then we're going to turn all the LEDs on if the temperature is bigger than 4 degrees higher than base temp. So high, high, high. So this will turn on 1, 2, or 3 LEDs, or no LEDs, depending on the temperature. If it's less than 28, all off. If it's between 28 and 30, the first one is on. If it's between 30 and 32, the first 2 are on. And if it's higher than 32, then all of them will be on. Okay, so the one last thing, we're going to put a delay in here. We'll wait for a second. And this is a pretty good idea because if you're trying to read analog too close together, then you can sometimes screw things up. It'll sometimes freak out. And that's the end of our loop. So now, let's just find out if this all is viable code. Okay, it worked. Now it's time to upload to the Arduino. Click that button to upload, and then we'll see if yours works. Now our sketch has been uploaded to the Arduino, and it's running. And so I'm going to show you how to use the serial monitor. So this little thing that says monitor and has a little magnifying glass by it, if you click on that, it opens the serial monitor. And now you can see that it's printing just exactly what we wanted it to do. The temperature right now is 26 degrees Celsius, 78 degrees Fahrenheit, 299 Kelvin. And it just repeats that every second, because that's what we told it, delay 1,000 milliseconds. And it's repeating that. Let me add to this video of the actual device. So as you can see, no lights are currently lit. And this isn't going to be really accurate because there's a little bit of a lag here. But I'm going to move my finger over to the Arduino, and I'm going to pinch the thermistor to add body heat. Watch what happens to the Celsius temperature. It rises. When it gets above 28, 1 light. When it gets above 30, 2 lights. When it gets above 32, 3 lights will light. Maybe I'm not hot enough to get it to 32. There it goes. On your monitor, it's above 32. You've not seen it yet. There, now all 3 lights are lit. If I take my finger away, let it cool down, the 3 LEDs, they'll go out as the temperature on the serial monitor drops down to below 28. So that's how you can use serial monitor to monitor the progress of what's going on in a sketch. I hope this helps you with your synchronous project and gives you a head start on doing the asynchronous activities for today.